So where would we start this problem? Okay, there's an x on each side. We have to get rid of one of those. So we're going to get rid of the smaller one, which is the 1.3x. So we subtract 1.3x. On the right side, all that's left is the 5.1. But now if we take something off one side, of course, we have to take it off the other. So we have to subtract 1.3x from the left side as well. Where do we take it from? 3.4x. So we're going to subtract 1.3x from 3.4x to get 2.1x. Anything else? We still have the negative 7.2 or minus 7.2 yet. I'm going to bring that down. What's next? We're going to add 7.2 to both sides. So we now have 2.1x equals 12.3. Now what do we do? Divide by 2.1, which is going to give us what? X is 5.85714,286 approximately.
Yeah.
Or 5 6/7, yeah. Okay. You got to be careful though. You could round it up to 5.9, but you cannot round it to 5.90. Okay? Because 5.9 is rounded to the nearest tenth, but 5.90 is implying that it's rounded to the nearest hundredth, and that would not be an accurate rounding. It would be 5.86, the nearest hundredth. So be careful about putting those extra zeros on the end. Okay. Any questions on that? Okay, well then, since we're trying some, I'm going to have you try this one as well. Evaluate Evaluate 7.2p minus 3.3m over 2q for p equals 4.8, m equals 2.4, and q equals 0.7. So give that one a shot quick. See what you come up with when you evaluate that. So tell me where to start. Plug in the numbers, okay? So what's that going to become? 34.56. Well, 7.2 times 4.8, okay, minus 3.3 times 2.4 over, so 2 times 0.7. I'm back to using the little x's for multiplication just so they don't get confused with the decimal points. Okay, now it's just an order of operations problem. It's got decimals in it, so it's a little uglier, but it's still order of operations. What do we do first? Yes, this fraction bar tells us we have to do everything on top first. And up there, there's no enclosing symbols, no exponents, so we're back to multiplication and division. So we do 7.2 times 4.8, which is 34.56. Then what? Yeah. We do the 3.3 times 2.4, which is 7.92. Then we're going to subtract to get 6.64 on top. What do we do then? 2 times 0.7 is 1.4. Then we divide. So when we divide, we get 19 and 1/35. 0.0285714,285. Yeah. Okay. That is it. Yeah. 19.02857, blah, blah, blah. Or 19 and, said 135th. Yeah, that works too. So, a lot of fun with decimals. So anyway, we're going to start off today then, our new material. We're going to start looking at percents. Percents are one of the most powerful tools in math. So, we're going to spend a considerable amount of time with them. To understand percents and how they work, we first have to understand the word percent. It's actually two words, per and cent. Per, if you think of like miles per hour or miles per gallon, it's for each or out of. Cent, if you think of cents in a dollar or years in a century, it is 100. So the word percent literally means out of 100. So if I say 37%, what that really means, what that actually is standing for is 37 out of 100, just like that. It's a ratio. In fact, this percent symbol, it looks like that. Actually, technically, it originated like this. What does that look like? On some of your calculators, that's actually what the fraction button looks like. That's a generic fraction. That's where this percent symbol actually came from, is that through the years they sped it up and started drawing the boxes. They drew little circles, and that's the percent symbol. So it actually is a ratio. So it is actually just that simple to turn any percent into a fraction. 37% is 37 out of 100. Now, of course, if I had something like 64%, that's going to become 64 out of 100, but we wouldn't leave it like that. What would we want to do with that? Reduce it. Both of those numbers can be divided by 2 will work. Gives us 32 out of 50. Are we done? No, both of those can be divided by 2 again, giving me 16 out of 25. So 64% is the same as 64 out of 100, or 16 out of 25. So how about 35%? What's that going to become? 35 out of 100. Good. Are we going to leave it there? No, that can be reduced by 5 to give us 7 over 20. Perfect. How about this? 340%. Oh, it's 340 out of 100. Now we notice there's a couple of things we can do there. First is, it's an improper fraction. 340 is bigger than 100. So I would probably do that first. How many times can I take 100 out of 340? 3 times, and how much would be left over? 40 100ths. Now, of course, I can reduce that fraction by, well, by 20. Yep. If I had both by 20, it gives me 2/5. All done? What I got to remember the 3. Very good. 3 and 2/5. So 14.6%. If I want to turn that into a fraction, what's that going to become? Yeah, 14.6 over 100. Now, we don't like having decimals within our fractions. And when we're dividing decimals, how do we get rid of those decimals? Multiplied by 10 or 100 or whatever. How many decimal places do we have here? 1. So we only have to multiply by 10. So 14.6 times 10 is 146. 100 times 10 is 1,000. Now that can be reduced by 2. Give us 73 over 500. Can we reduce that any further? So what can 73 be divided by? The answer is nothing. There you go. So 14.6% reduces to 73 out of 500. How about 36 2/3%? What's that going to be as a fraction? Well, it's 36 2/3 out of 100. Now, if I want to get rid of a fraction, remember when we were solving equations with fractions in them, how did we get rid of the fractions? We multiplied by a least common denominator. Well, here there's only one denominator, which is 3, right? It's the only denominator. So if I multiply the top and bottom by 3, that'll get rid of the fractions. That's my least common denominator. I'll do the bottom for you. 100 times 3 is 300. On top, 36 2/3 times 3, we're going to have to do 36 times 3, which is 108, plus 2 is 110. So that's 110 over 3, changed into an improper fraction, times 3, well, that's going to become 3 over 1, isn't it? Now you're going to cross cancel the 3's to get 110 over 1, which is, of course, 110. So 36 2/3 over 100 becomes 110 over 300. And what can I do with that? I can divide both of those by 10, because they're both ending 0. Give me 11/30. So 36 2/3% is the same as 11 out of 30. Is it cold in here? Is it? See, I don't notice because a lot of heat comes off of these machines up here, so it's like 4 or 5 degrees warmer up here. So if you want to take over and teach the class, it'll warm you up. Not worth it. I don't think you'd get a lot of arguments from the class, no. I want you to convert each of those 3 into fractions reduced to their lowest form. So 62.5% becomes 62.5 over 100. Then what do we do from there? Times 10. So 625 over 1,000. And then both of those can be divided by 25, which is going to give us 25 over 40. And then they can still be reduced by 5. Giving us 5/8. 5 out of 8. Very good. 18 1/3% becomes 18 1/3 over 100. And then times by 3. I'll do the 100 times 3 is 300. What's 18 1/3 times 3? 55, right? 18 times 3 is 54, plus 1 is 55, so it's 55 over 3 times 3 over 1, which is 55. Then what? Reduce by 5 to give us 11 out of 60. So 18 1/3% is 11 out of 60. And finally, 484% is going to become 484 out of 100. And that'll reduce to, well, first thing I'd do is make it into a mixed number, which would be 4 and 84 hundredths. And then divide by 4. 84 divided by 4 is 21. 100 divided by 4 is 25. All done. Add the 4. Perfect. 4 and 21 25ths. How do you guys feel? That's really hard. Easy. There you go. Those are the magic words.
We're going to need a lot more examples.
So we said 37% was 37 out of 100. Remember, we've been over this before. Totally heartless. So 37 out of 100, if you want to turn it into a decimal, we're going to divide it. 37 divided by 100 is 0.37. To turn any percent into a decimal, since it's out of 100, it's divided by 100. And when we divide anything by 100, all it does is move the decimal point over 2 spots, like that. So 84% is going to become what as a decimal? 0.84. 9% is going to become what as a decimal? 0.09. 51% is going to become 0.51. 270% is going to become 2.7. Good. 8.3%. 0.083. 0.4% is going to become 0.004. And here's the one I always get people on. 1/4% is going to become
0.0025.
there it is.
Yeah.
0.0025. Good. Most people just yell out 0.25. But you change that to 0.25, that's still a percent. Now we have to divide by 100, which will get us to the 0.0025. Very good. One way to think of it, I like to, when I do with percents especially, but anytime I am dealing with numbers, I think of benchmarks. We talked about the rounding and stuff when we do our operations. Well, the same here. What is 1% as a decimal? 0.01. Is 1/4% bigger or smaller than 1%? It's smaller. So its decimal better be smaller than 0.01. If I want to go the other direction, if I have a decimal like 0.63 and I want to turn it back into a percent, a decimal is always out of 1. It's 0.63 over 1. A percent is always out of 100. Very good. So to adjust this, of course, to turn the 1 into 100, it was times 100. To turn 0.63, I'd have to also multiply by 100 to give me 63. So that's telling me that it is 63 out of 100, or 63%. So if I have, of course, since I'm just multiplying by 100, it just means I'm moving the decimal over 2 spots. So if I have 0.28, what's that going to become as a percent? 28%, right? Or 28 over 100, which is 28%. If I have 0.94, what's that going to be as a percent? 94%. 0.3 is going to become what as a percent? 30%. Good. What's that? 2.9 is going to become 290%. 0.062 is going to become 6.2%. Good. 4.374 is going to become 437.4%. Good. And 0.08 will be 8%. Good. So in your notes, have you convert some into percents and some into decimals. We're starting to convert to decimals. 48% 273%, 9.1%, and 0.6%. Convert those into decimals, and then convert these decimals into percents. 0.2, 3.8, 0.096, and 0.55. So do those conversions quick in your notes. Okay, so 48% as a decimal is 0.48. 273% is 2.73. 9.1%. 0.091. 0.6%. 0.006. Going the other way from a decimal, 0.2 becomes what is a percent? 20%. 3.8 becomes 380. 0.096 becomes 9.6%. And 0.55 becomes 55%. So only one thing left to do, and that is to go from a fraction back into a percent. And we're going to start with one that we already know just off the top of our head. 3/4 becomes what percent? 75%. Most of us knew that one without having to do anything with it. But if we didn't know it, there are a couple of ways you could have approached it. One is you could have converted 3/4 into a decimal. 3 divided by 4 is 0.75. Then just move the decimal point, 75%. That works. Or we could have done the equivalent fractions. 3/4, remember, any fraction can be thought of as a ratio. So 3/4 can be thought of as 3 out of 4. Well, percent is always out of 100. So we need to figure out how to make that out of 100. Well, to turn a 4 into 100, we would multiply by 25. So I have to multiply the 3 by 25 as well, giving us 75. So 75 out of 100, or 75%. Now, sometimes that's not as easy to do, to figure out what to multiply that denominator by to make it into 100. For example, we might have 7/8. If I want to turn that into a percent, what do I multiply 8 by to get 100? Well, I suppose we could always do 8 divided by 1, or 100 divided by 8, which is 12.5. But that's kind of tedious. And you would multiply both of those by 12.5 to turn it into hundreds. So what you'd end up doing, 100 divided by 8, and then you're going to multiply 7 by that. Well, a process that simulates that, puts that all together, that we use, and we saw this before when we did our ratios and proportions, is to cross multiply and divide. How do we cross multiply? Yep. There's two numbers that are on a diagonal together, and that's the 7 and 100. So 7 times 100 is 700. And then the number that's on the other diagonal by itself is the 8. We divide by the 8, which is going to give us 87.5. So that's 87.5 out of 100, or 87.5%. So if we want to convert something like 2/7 back into a percent, it's 2 out of 7, and we're asking how much is that out of 100. So 2 times 100 is 200, and then divided by 7, which is going to give us 28.5714286 approximately. Now, the question comes up, how far are we going to take it? Well, my math lab will usually specify to you round to the nearest either 10th or 100th or 1,000th of a percent, usually 10th or 100th. Let's say it tells us to round to the nearest 100th percent on this one. So where's the 100th? The 7. So is it going to go up to 8 or stay 7? Stay 7. So 28.57%. So what if I want to the nearest 10th? 4/11ths. Well, it's 4 out of 11. 4 over 11 is how much out of 100? We will cross multiply. 4 times 100 is 400. Divided by 11 is 36.3636. Now notice I still went a few places, even though I'm going to round to the nearest 10th, because I at least have to have that next digit. The 3's in the 10th place. The 6 tells me that this is going to become 36.4%. So let's have you try a couple. Let's have you take 7/9 to convert into a percent. Let's have you do 3 2/5 into a percent. Let's have you do 3/80 into a percent. So do those 3. To the nearest 100th. So nearest 100th percent. So 7/9 becomes 77.78%. Good. Let's do 3/80 becomes 3.75%. That one didn't need to be rounded. And 3 2/5. 340%. Very good. The first step would be to change this into an improper fraction. 3 times 5 is 15 plus 2 is 17/5. And then 17 out of 5 equals how much out of 100? And cross multiply. 17 times 100 is 1700. Divided by 5 gives us 340. So 340%. Any questions? Now, I mentioned the idea of bookmarks. Or benchmarks, I should say bookmarks. Benchmarks. Wow. It's nap time. Benchmarks. First thing, to understand benchmarks, again, we have to understand this meaning of percent. So for example, 67% of 100 should be really simple. Because 67% of 100, 67% means 67 out of 100. So out of 100, 67% is 67. If we were looking for 67 out of 100 and we have 100, we have 67. Or 35% out of 100 would be 35. What if I alter that slightly and I say 35% of 200? Well, 200 is just 100 and 100, isn't it? 35% of 100 is 35. So out of each of those hundreds, we take 35, so we have 70. It makes sense. If 35% out of 100 is 35, out of 200, it would just be double that, wouldn't it? That's what I was talking about benchmarks. Or if we had something that started, let's say we start with $100. And it goes up to $114. What percent was our increase? Well, how much was our increase? $14 increase. So $14 out of $100 is 14 out of 100. So it is a 14% increase. So those benchmarks are pretty simple. They're just the hundreds. But there are some others that are also fairly simple to do. 10%, for example, means 10 out of 100. Now 10 out of 100 is 1/10. To find 1/10 of something, it's pretty simple. What is 1/10 of 60? 6. 1/10 of 28. 2.8. How did we get those numbers so quickly? They're dividing by 10. When you divide by 10, all you're doing is moving a decimal point, right? Move it over 1, 60 becomes 6. 28 becomes 2.8. So 10% of something is just moving the decimal point. So 10% of 490 is going to become 49. Good. 10% of 6,984 is going to become 698.4. 10% of 76 is going to become 7.6. So that's a pretty easy benchmark. 1% means 1 out of 100. No reducing that one because it's already at 1. But 1 out of 100. Let's find what is 1% of 900 going to be? 9, right? If 1% of 100 is 1, 1% of 900 has to be 9. What's 1% of 30 going to be? 0.3. How do we get that? Well, 1% is 1 out of 100, or dividing by 100. So to divide by 100, I just move the decimal point 2 spots. 900 becomes 9. 30 becomes 0.3. So if I want to find 1% of 260, what's that going to be? $2.6. If I want 1% of 740, that's going to become 7.4. 1% of 8,300 is going to become 83, or 1% of 92 is going to become 0.92. Very good. If you get stumped, of course, 1% of 100 is always 1, so 1% of 92 has to be smaller than 1. Ones that are not quite as simple. 50%. 50%, of course, is 50 out of 100. What fraction does that reduce to? 1/2. So if I'm asked to find 50% of something, I'm asking you to find half. So what is 50% of 32? 16. 50% of 460. 230. Good. 50% of 27. A little bit trickier, isn't it? 13.5. Very good. So 50% is just half. How about 5%? Now I could go through 5%, it's 5 out of 100, which reduces to 1 out of 20. Doesn't do us a whole lot of good because many of us are not that great at dividing by 20. But how does 5% relate to 10%? It's half of 10%. So if I want to find 5% of something, let's say I want 5% of 580. Well, 10% of 580 is 58. Half of that is 29. So 5% of 580 is 29. 5% of 1,400. Well, again, 10% is going to be what? 140. So half of 140 is 70. 5% of 1400 is 70. So there's all sorts of benchmarks out there that are extremely easy to calculate once you get thinking about them. And we're actually going to use these benchmarks when we come back from break to start doing some very simple calculations. And then, of course, we'll get into an actual exact calculation method. So for right now, we're going to take our break. It's 4:19. Let's come back at 4:29.